tell you how a bicycle works. Basically, it is a machine that converts energy from one form, that is the food you eat, to another form, that is the kinetic energy with which you will travel on your bicycle. You will be really shocked to know that bicycle is the most efficient transportation device ever made by humans so far. Harnessing the power from your muscles in an amazingly effective way, it converts approximately 90% of the energy you supply at the pedal into the kinetic energy with which you will move along. Compare that to a car engine which converts only 1/4 of the energy in gasoline to the useful form and makes all kinds of pollution in the way.
Handlebar. Bicycle handlebar, or often bicycle handlebars, refer to the steering mechanism for bicycle, the equivalent of a steering wheel. Besides steering, handlebars also often support a portion of the rider's weight depending on their riding position and provide a convenient mounting place for brake levers, shift levers, cyclocomputers, belts, etc. Handlebars are attached to a bike's stem, which in turn attaches to the fork. Stem. The stem is the component on a bicycle that connects the handlebars to the steerer tube of the bicycle fork. Sometimes called a gooseneck, a stem's design belongs to either a quill or a threadless system, and each system is compatible with respective headset and fork designs. Headset. The headset is the set of components on a bicycle that provides a routable interface between the bicycle fork and the head tube of the bicycle frame itself. The short tube through which the steerer of the fork passes is called the head tube. Fork. The bicycle fork is the portion of a bicycle that holds the front wheel and allows to rider the steer and balance the bicycle. A fork consists of two fork ends which hold the front wheel axle, two blades which join at fork crown, and steer or steering tube to which the handlebars attach, allowing the users to steer the bicycle. The steerer, the fork interface between the frame via a set of bearings known as headset mounted in the head tube. Seat post. The bicycle seat post, seat pin, saddle pole, saddle pillar, or saddle pin is a tube that extends apart from the bicycle frame to the saddle. The amount that it extends out of the frame can usually be adjusted, and there is usually a mark that indicates the minimum insertion. Seat post can be made of steel, aluminium, titanium, carbon fiber, or aluminium wrapped in the carbon fiber. Saddle. The bicycle saddle, often called seat, is one of the three connect points on an upright bicycle, the others being the pedals and the handlebar. Bottom bracket. The bottom bracket on a bicycle connects to the crankset, this is also known as chainset, to the bicycle and allows the crankset to rotate freely. It is not a bracket as such. It contains a spindle that crankset attaches to, and the bearing that allow the spindle and cranks to rotate. Tire. A bicycle tire is a tire that fit on the wheel of a bicycle, unicycle, tricycle, quadricycle, bicycle tire, or trailer bike. They may also be used on wheelchair, handle cycle, especially for racing. Bicycles tires provide an important source of suspension, generate the lateral force necessary for balancing and turning, and generate the longitudinal force necessary for propulsion and braking. Spoke. A spoke is one of the some number of rods radiating from the center of a wheel, connecting the hub with the round traction surface. Pedal. A bicycle pedal is the part of bicycle that the rider pushes with their foot to propel the bicycle. It provides the connection between the cyclist's foot or shoe and the crank, allowing the leg to turn the bottom bracket spindle and propel the bicycle wheels. Set. Crankset. The crankset or chain set is a component of bicycle drivetrain that converts the reciprocating motion of the rider's leg into the rotational motion used to drive the chain or belt, which in turn drives the rear wheel. It consists of one or more sprockets, also called chain rings. Chain. A bicycle chain is a roller that then transfers power from the pedals to the drive wheel of a bicycle, thus propelling it. Most bicycle chains are made from plain carbon or alloy steel, but some are nickel plated to prevent rust or simply for aesthetic. Nickel also confers a measure of cell lubrication to chains moving parts. Nickel is relatively non-galling metal. Sprocket. A sprocket or sprocket wheel is a profiled wheel with teeth, coves, or even a sprocket that mates with a chain, track, or other perforate or intended material. The name sprocket applies generally to any wheel upon which are radial projections that engage a chain passing over it. Brake. A bicycle brake is used to slow down or stop a bicycle. There have been various types of brake used throughout history, and several are still in use today. The three main types are rim brakes, disc brakes, and drum brakes.
Explain you about the working of brakes in the cycle. Here you can see this is the brake and this is the thin metal wire which is connected to the, this metal wire is connected to the front wheel and this is to the rear wheel. And now if you ride a bicycle, uh, then so if you are riding a bicycle and suddenly any obstacle comes in front of you, then you apply sudden brake and you expect this to that it brings you to a safer stop. But this brakes uses the power of science, and thankfully in the most cases the science doesn't let us down. If we ride on a bicycle, then we have the mass, and if we are riding, then it has velocity. And the more mass we have, then it has more kinetic energy. And if we want to stop the cycle, then we have to get rid of this kinetic energy. And how we get rid of this kinetic energy? Through the use of brake. Now, if we apply brake, then brakes on the handlebars here, then this wire which is connected to the front wheel, it squeezes this a small here, and this rubber, it presses against the rim. This rubber presses against this rim, and this wire which is connected to the rear wheel here also, this clipper, this forces this rubber to press against this rim. And when this rubber block presses against this rim, then a friction between, when they do so, a friction between a rubber block and this rim is created. And due to this friction, a heat is generated here and here. You can see when you press this, then through this, when we press this, then this through this here, when this rubber block is presses against this rim, then a friction between this rubber block and rim is created. When they do so, a heat is generated between here, and thus through this, when heat is generated, then we get rid of this kinetic energy, and we safely bring to a our bicycle to a stop. This is how the brake works in a cycle and makes us help in stopping the bicycle when a sudden obstacle comes.
Okay, so now let's see why does a bicycle move only in forward direction and not in backward direction. If we move our pedal in the right direction, we can see that the tire of the bicycle as well as the silver colored central part of the bicycle moves. But now, if I move my pedal in the wrong direction, we can see that only the gear and the chain of the bicycle are moving and the silver colored central part is not moving. The tire moves in the right direction, the red part gets stuck in the blue part, which in turn makes the blue part move, and hence the whole bicycle moves. But when you pedal your pedal in the wrong direction, the red part can't get stuck in the blue part, hence only the green and the red part move inside the blue part, hence which does not make any effect on the bicycle.
Mechanical advantage bicycle. Before finding the mechanical advantage, let us know about pedals and sprocket gears. Special gears with elongated teeth are connected with a chain. These gears, pedals, and sprocket are found quite common in bicycles. They operate the same way as gears except that the direction of the rotating gears is not reversed. When the last pedal gear toward the front of the bicycle revolves, the chain pulls round the sprocket gear wheel at the rear in the same direction. Gear ratios and mechanical advantage are calculated via the same formulas used for gear system. So, mechanical advantage is output force upon input force, which is also equal to distance moved by the effort force and distance upon distance moved by the resistance force. Or simply we can say that total number of teeth in rear gear upon total number of teeth in front gear. So as we know that there is 44 teeth in front gear and 18 teeth in rear gear, so MA is equal to 18 upon 44, which is equal to 0.409 and approximately 0.41, which is our mechanical advantage of bicycle. Now notice that in every case the force on the pedals is greater than the force driving the bicycle forward. This low mechanical advantage keeps the pedal crank speed low relative to the speed of the drive wheel even in the low gears.
Now I'll be telling you about the distance the cycle travels when you pedal in once. Now I'll be taking a mark of reference in the rear wheel as I am marked with a black marker here. Now I will be pedaling once and seeing the number of evolutions the rear wheel makes. Now, by observing it, we can calculate that the number of revolutions the rear wheel makes is 4.5. Now, by putting the values in the formula of circumference and the number of revolutions, we can calculate the distance the cycle travels, which is roughly equal to 8 meters. Thus, we can see when we pedal in once, the cycle makes a distance of 8 meters. Now, you can observe me while I will be riding the cycle. As my foot is here and I will be making the same distance. The distance from this point and to this point, we can calculate that this is roughly equal to the 8 meters.